Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing on in our unit on systems of equations, but this time we're going to be looking at modeling situations using systems of equations. So, suppose that in one stunt, two Cirque du Soleil performers are being launched toward one another from two slightly offset seesaws. The first performer is launched, and then 1 second later, the second performer is launched in the opposite direction. So they're flying towards one another. They both perform a flip, and then they give each other a high five in the air. Each performer is in the air for roughly 2 seconds. The height above the seesaws versus time, so seesaw height is going to be on the y-axis and time on the x-axis, for each performer during the stunt is approximated by the parabola shown. So they've given us a parabola here where you have height above the seesaw on the y-axis and time on the x-axis. And we can see the first performer and the second performer going and doing their jumps, and they're intersecting somewhere where they're doing their high five, and the paths are being shown on that grid. Okay. So we're being asked to determine the system of equations that models the performer's height during the stunt. Let's give that a shot. Okay, well, what do we know? Well, we know that the first performer here in teal, the vertex is at 1 and 5. And let's see, what's the A value? If we go right 1, does it? No. So we're going to have to calculate the A value here. But what we do know is that it's going to be y equals a x minus p, and our p value is 1 squared, plus q, which is 5, because our vertex was 1 and 5. So there we go. We have that. Now we can apply a different set of points. So this one was 1 and 5. Let's pick another point. How about 0, 0? That's an easy point to choose. So let's plug in our y and x values of 0 and see what happens. So we have 0 equals a times 0 minus 1 squared plus 5. So this is going to be 0 equals a. 0 minus 1 is negative 1 squared plus 5. All right, let's move this 5 over. So we're going to have negative 5 equals, I subtracted 5 from both sides. Negative 1 squared is 1. 1 times a is a. So a is negative 5. All right, now we can plug that back into our equation up here. So our first equation is going to be, we'll write that here. Our first equation is going to be y equals 5, x minus 1 squared plus 5. Let's go ahead and box that, because that's our first equation. Now, let's work out our second one. So the second performer, the vertex of their equation is here. That's at 2 and 5. So y equals a x minus 2 squared plus 5. And let's choose this point here. So this is 1 and 0. So 0 equals a, x value is 1 this time, minus 2 squared plus 5. 0 equals a, 1 minus 2 is negative 1. Okay, plus 5. Let's subtract this 5 to the other side. That's squared. So negative 5 equals negative 1 squared is 1 times a. It's the same. So this time we have y equals, that should be negative. I'll fix that in a second. Negative 5, this time it's x minus 2 squared plus 5. And of course we noticed a problem over here. This should be negative 5 because we found our a value to be negative 5. I'm just going to fix that up, make sure it looks good. Negative 5. All right, and there's our two equations. Let's just put the vertex up here. There we go. Solve the system graphically using technology. Okay, this is something we haven't done yet today. Let's go ahead and do that. So we're going to hit Doc, File, New, Add Graphs. Now for our f of x, the first one, it's going to be -5 x minus 1 squared plus 5. And we're going to graph that. There we go. So there's our first equation. Now we're going to hit Menu, Graph Entry, and we're going to enter a new function, f2. -5 x minus 2 squared plus 5. And we're going to graph that one. So there's our two functions, and we're going to find our solution. So to find your solution, you're going to go Menu, Analyze Graph, Intersection. And we're going to look for our intersection. I'm going to highlight this point and drag here because we can see that there's one intersection. And so you're just going to drag it before and after the intersection. And you can see here in black. Here, let me get rid of this. I'm going to hide that label. We know what our functions are. And there we go. We found our intersection. It is, let's write it down on the screen here. It is 1.5 and 3.75. And if we look here, so there's 1.5. You know, we couldn't really see where it was, but does that look like 3.75? Yeah, pretty close. So we might have been able to guess it, but here we know for sure by solving using technology. Interpret our solution with respect to the situation. Let's think about what's going on for a second. What does this mean? Well, it means that 1.5 seconds after the first performer jumps and 0.5 seconds after the second performer jumps, they're going to be at the same height, 3.75 meters above the seesaw, and that's where they're gonna give each other a high five. All right, so that's the solution for this. It's going to be your turn. Go ahead and try modeling this situation. You're answering this question. Two numbers have a sum of 17. The square of the first number plus 5 equals the second number. What are the two numbers? So this isn't a real life situation. This is modeling a word problem. To do this, let x represent the first number and let y represent the second number. Then you're going to create a system of equations using that information, graph it, and interpret the points of the intersection. Go ahead and try this out and come back when you return for the solution. Okay, welcome back. I have the solution here for you. Let's go through it. So two numbers have a sum of 17. X is the first number, y is the second number. So two numbers added together, the sum of two numbers equals 17. That's the first part of this. And then of course you want to isolate y. So y is equal to -x plus 17. Then we're told the square of the first number, and the first number was x, so the square of the first number plus 5 equals the second number. So plus 5 equals the second number. And there we have two equations. Y equals -x plus 17, well that's just, that's a line, right? So you go to plus 17, so I have to change my axes here. So each box is 2, and so here's 10, 12, 14, 16, 17. So there's my y-intercept, and a slope of -1 allows me to plot my line there in red. Now x squared plus 5 equals y, so that's basically, you can think of it's a normal x squared graph. When I say a normal x squared graph, I mean y equals x squared. They look very similar, except it's being shifted up 5. And so normally your x squared graph would start right there at the origin, but now it's going to be shifted up 5, and it's going to look exactly like an x squared graph except for being shifted up 5. Now you can see the points of intersection are here and here. These points are at 3 and 14 and negative 4 and 21. So we graphed our system, and then you want to determine, well, we already did determine the points of the intersection, but you want to test them. And of course, they work for both. Let's go ahead and solve this graphically as well, just so you can see how easy it is. We're going to create a new document, add a graph. Our first function is negative x plus 17. We're going to go ahead and graph that. You can kind of see here, it looks like it's off the screen. So we're going to zoom out, and there we go. Now we can see it. Then we're going to add in our second function, which is x squared plus 5, and graph it. Now you can see clearly there's 2 points of intersection, so we're going to find them. We're going to analyze our graph, go intersection. On the left of both the intersections, we're going to click, drag it over. Let's do the first one first. So there we go. And you can see, let me hide this again. It's negative 4 and 21, which is what we found when we did it by hand. Now let's go and find the second intersection, so before and after the point, and we can see 3 and 14. We found them both. There we go. That's it for this lesson. Stay tuned. In lesson 2, we're going to be looking at solving systems of equations algebraically. See you next time. Bye-bye. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.